Welcome to part 10 of the WUDSN IDE tutorial series. Today I would like to show you how you can extend WUDSN IDE with support for your own or favorite assembler that's not yet part of the standard deployment. First of all, you have to install Eclipse in a supported version of WUDSN IDE. You have to install WUDSN IDE itself. And if you do so, then you get several plugins in the plugins folder. And these plugins do not only contain the binaries required to run the IDE, they also contain all the sources. So there is no separate source project. All WUDSN IDE contains the complete set of its sources. So what you can do then is you can import the plugins from the active platform where you have them installed, and you import them as projects with source folders. You press next, you search for the WUDSN IDE stuff that's not yet imported. You would click add and finish. I don't do that because I already did it here. And if you do that for all the included plugins, then you get this tree that you see here with a number of different plugins, all starting with the same common prefix com WUDSN IDE. So what's in there? Well, first of all, there's the base package where you typically don't have to change something. This includes common routines for input, output, logging, handling of files, and so on. The base feature is not interesting. Then there is support for disk images, which we leave out for the moment, graphics, the hex editor, reference projects, this we will see in a second, sound editor, it's also not that interesting, and some test. And the most important things for us today are the first three: the core assembler package, the support with the different existing compilers, and that's also included in the standard, there is already a project foreseen for your extensions. That's the test project, and it contains already a test assembler that you can just use as the basis and modify it. And that's what we're going to do today. So after you set up this workspace with all the required plugins, you should define a run configuration to actually run the IDE. So here I have a run configuration. For WUDSN IDE, it started as a platform IDE. The standard platform arguments that are usually specified. Make sure you have enough memory assigned, especially for the perm size. And basically that's it. And if all that is correct and you start your run configuration, then Eclipse starts a new instance. And in that new instance, I now have here my standard folders for test purposes. And if I go here to, let's say, the Atari 800, I have my reference sources, which I typically use. And if I now go here to the preferences in the assembler section, then you see the normal for all the platforms. You see here compilers, and you also see here that there is a test compilers section. So that is for a new hardware. So the examples include a test hardware, pseudo hardware that you can use if you want to add support for a new platform which is not even listed here. Also, if you go to each of the existing platforms, you will see test compilers. So here you have the assembler, and here you do not only have the standard support ones, you also have here already prepared a placeholder for your own assembler or compiler. And this then also shows up for configuration in the corresponding hardware sections. So what we are going to do is we are going to modify the existing test compiler to support the Apple II platform. And the reason behind that is that what we want to add as an example is Merlin 32, a very recent cross-assembler for the Apple II platform. So what I do is, first of all, I close the instance that I have started, and I check now what's in that test compiler package that's already provisioned there. So first we have the plugin XML file, which defines the basic properties and dependencies of the additional plugin. In this plugin we find here several extensions that were added via extension points. The first one is the test compilers preferences page. This is something we don't need. This we would only need if we add a new hardware. Yeah, but we don't add a new hardware, we only add a new compiler for the existing hardware of Apple II. So we have here the test compiler, and here now we specify the IDs. I leave it as test. There are some properties for the class, all of them I leave unchanged. Later on, of course, I would rename them to really reflect that it's Merlin, but for the time being I don't change that. There's a certain version. This is the information for which version WUDSN IDE, which version of the compiler WUDSN IDE actually supports. And for Merlin it would be 1.0 because that's the only version of Merlin that's currently out. Then we need to specify the default parameters. So how do we run the compiler? So these are the default parameters passed on to the command line when executing the compiler later on. This we would have to look up in the documentation. Then we specify the default hardware for the compiler to be Apple II. And we specify the homepage URL of the compiler to be Brutal Deluxe. Okay, I already checked the download. There are no standard help files included in Merlin 32, so we leave that blank for the moment. So what else do we have? We can have file types. So we would have a new file type. And the file type for this would then be a Merlin source file. And the standard file extension that I found here is that it's .s, I think. Yes. For .s we just put an s. And that's it. Then here we have the editor. So in Eclipse, if you open a certain file and it's bound to an editor, and the editor actually determines which compiler is used. So we register this editor to, by default, use the S extension. We can also browse icons. There is a set of icons already included. Also in this folder that you can use if you use a different platform, or maybe the product itself actually has an own icon. That's all fine. We leave the existing icon. And the next thing that we can add are runners. Runners are applications that run the output of the compiler. Typically, these are emulators. This is an example of where additional emulators can be added via an extension point. In the case of Apple, we also don't need that because already the different emulators for Apple are included in the standard compiler package. Yeah, so maybe we just go here to give you an example what's all in the standard already. Here you find the different compilers. Here you find the different content types for the source files. You find for each compiler an own editor with a nice icon. And then we have runners for the different platforms, like here it's Apple, VCS, Atari 800. So, and all the emulators are typically already there, so let's focus on the assembler itself. So this was the plugin XML. All the translatable text of the plugin XML are actually in here. So what we do is we don't need the test compilers, because that would be Apple. That's the extension that we don't use. So we have the compiler name, which would be Merlin 32. It would be a Merlin 32 editor. It would be a Merlin 32 source file. And again, the runners we don't need for the example. There is also by default a German properties file, which of course you don't necessarily need. Yeah, that's it already in terms of metadata. So let's start it again and see what it looks like. So if we now go to the preferences, we see here under Apple II that now there is no longer a test but a Merlin 2. I have not configured the path to a binary yet. That's why it's not showing up here for configuration. Yeah, so I would first have to specify the binary here for testing, but for the time being we don't even need that. So let's close this. So what else do we have? What else do we have in the source? So that was actually it with regards to the plugins and the properties. So now the interesting parts comes in the sources. There we again find 3 subpackages, all with the suffix .test, and you will find the same structure here in the standard, where we have compilers, editors, and they are one-to-one. The runners are actually per platform, and the preferences are per emulator, and the preferences are per platform, because we don't care about new platforms or emulators here. We focus on the compilers. So for the compiler, first of all, you need to create a new class. This class simply instantiates 2 delegate classes, one for the source parser and one for the log parser. All the compilers are called via the command line interface. Their output on standard out and standard error is recorded and parsed, so it can be used for display in the problems view or whatever else is there. So this is just the heading, the leading class that still on demand creates instances of the delegate classes. So we have the source parser, which comes with a standard implementation, and it mainly has to deal with parsing individual lines. I would say 90%, 95% of the parsing is actually done by the standard implementation. Only there are some specifics, typically when it comes to origin statements and assignments, that need to be handled differently. For the log parser, it's similar. So this is now a log parser for something that's similar to Mads. The log parser actually also has a base class that it extends, and it is called during the with an initialize to create some pattern that I then later on use to do pattern matching when scanning the source file. And the important method is actually find next marker. So this log file scanner then scans for labels. Yeah, for labels and for error messages in the source file. And when it finds an error message, it tries to extract the source code position that this error message refers to. So there is some hardcore string handling involved. You get the error log as an input actually to this method via a protected variable, and you can scan through this one string, which is the complete error log, and see if you find an error message. And if you find an error message, you extract the name of the source file and you extract the line number, and that's it. Yeah, that's hardcore string handling depending on how the output of your compiler looks like. And then there is a second method that is used for a similar purpose. If you switch some of the compilers to verbose mode, or sometimes you can activate a separate log file, then they put the symbols there. And again, here you have not the error log but the output log, and you would scan through this long string of the output log and try to extract the symbols from there so they can later on be displayed in the generic symbols view. Okay, so you've seen there's not much coding, but it's very specific to the compiler. And there is one generic thing, and that's now the extension of the instruction set defined by the compiler. In the ASM package, you can find the common definition of the 6502 opcodes. So everything that's an official opcode and no compiler specific directive, you can find in this compiler XML file. Yeah, so there are the opcodes, and this is actually parsed during logon, and also the legal opcodes from 65C02 and W65816. They are all in there. And you can think of it that this is already included, and on top of this you can now define the instruction set for the compiler. The XML file is found automatically by having the same name as the compiler class itself. And here you can now specify a number of settings that determine how the generic part of the parser and the syntax highlighting will deal with the source code that it parses in the editor. Yes, so what do we have there? We have a setting that's called completion proposal auto activation characters. Ooh, right. So what does it mean? If you type a dot, yeah, because this was for a compiler where many commands actually start with a dot. If you type a dot, then it will automatically do the same thing as if you press Shift Control Space, so the auto completion will start. Then we have the delimiting character for single line commands, which is here a semicolon. We have the delimiters for multiple line commands. Typically these are, if they exist, they are stars, for example. Then if there is a string in the code, then it depends. Sometimes compilers only accept double quotes, sometimes they accept single quotes, sometimes they accept both, and it has different meaning. So this is set up as a compiler that accepts double quotes. Because this is an XML file, you have to write it as an entity name here. So block definition characters are normally not used. They're a very specific feature. Don't go into the details now. Then there's a question if identifiers of labels and subroutines, if they are case sensitive or not. Yeah, that has influence on how the navigation behaves and how the label and symbol display behave. Then we have the characters that are valid start characters for an identifier. This typically contains A to Z and the digits. And also the lowercase characters, either because the compiler is case insensitive and it doesn't matter, or because it is case sensitive and it's different. And what you have in addition, there are sometimes start characters that are additionally allowed, like a question mark and the @ sign, frequently used to indicate local labels. Underscores, typically also allowed. And there are, as a second part, here are the characters that are allowed within an identifier. With these two sets of characters, the source code parser can determine where an identifier, a potential identifier, starts and ends for the syntax highlighting and the navigation. Then there is something called the identifier separator character. That is used for compilers that support qualified names. Yeah, so sometimes you can call procedures within procedures by calling them procedure A dot procedure B. Yeah, so you can have nesting and compound identifiers. If that's the case, then you have a separator character, and that's specified here. Label definition suffix character. Most compilers nowadays don't require a suffix character. In the old days it was common to have it, so if you write a label you would end the label with a colon, and you would have to end the label with a colon in particular. So then you would put the colon here if colon is an allowed suffix for a label definition. That's important because the colon then has to be ignored and not be considered part of a label by the parser. Yeah, then there are if there are macros, macro definitions, then sometimes these macro definitions also use special characters like a dot or a double or a colon. Yeah, and similar like we had this setting, if the identifiers are case sensitive, there is the question if the instructions themselves are case sensitive or not. Yeah, and the last thing is if you have a compiler directive for including source files, then it depends on the compiler. Typically you would have to specify the full source file name, including the extension, but there are compilers that allow you to omit the extension of the include file, and then the parser needs to know what the default, which default file extension the compiler would assume if you omit the file extension for a source include. Yeah, all this is meta information. You can see all this and maybe see how the other compilers are set up in the help section. So if I go here and I go to help, then we have here the assemblers. So what you notice is in the code they're all called compilers because it's done as a more general thing. Whereas in the documentation and the on-screen text you should also find assemblers. So let's go here, and if I now click on Mats, for example, then I have here the general, and this is now generated based on that settings in the XML file. Yeah, so exactly for Mats you will find a similar XML file, and here you see the information from the extension point, like what is the homepage, what's the hardware, supported CPUs, this we will see in a second, default parameters specified in the extensions, and now here starts this whole section with the delimiters, characters, and so on. Yeah, maybe I switch back to the supported, I think that I skipped those. I switch back to the plugin because here for the compiler, yeah, I only had shown you this one, and what you see here is that there is a dependent setting that you can have, and that's the setting of the supported CPUs. Yeah, so here I can say, I can say add a new supported CPU, and that's the set of supported CPUs, which means instruction sets combined with a CPU restriction that is supported. Yeah, and because two of them were listed here, if I look at the Merlin 32 general, then we now see here Apple, we see Brutal Deluxe, we see the two opcodes and the settings that we have done. Okay, those were the general settings. Now we have the instructions. There's already quite a lot. Why that? So first of all, you have the standard opcodes. Then you have illegal opcodes, you have pseudo opcodes, and you have directives. And yeah, major effort when you add a new compiler is to actually define all of them in this XML file. Yeah, so you have this general standard opcode thing that comes with the instruction set, that's for free. And then you have everything that's actually specific to your compiler. What you can specify here is you can add a directive, you can restrict it to a CPU, to exactly one of those CPUs that you have listed here. Yeah, because sometimes certain directives only make sense if you are in that mode. Then you can set a filter here, or you can omit the filter and put a star here. Then that's the technical name of the directive. That's the title. In the title you put an underscore in front of everything that has to be underlined because it is the short form of the corresponding opcode or directive. So type is directive, and the proposal is if you type auto-completion. So if I now open something here with a test, maybe we do make a Merlin. So let's create a folder, Merlin 32. And in here we create now a file, merlin.s. And I can say open with Merlin editor. You see now the icon is taken from here. And now the question is, if I type in a dot and we have end, then you see here the proposal that results from the directive definition that you have seen. And if I click it now, it puts in the end and puts my cursor there. I can have complex extensions like the if, which is supplied by if and end if, and the cursor is positioned in the middle. So let's see how this looks like. Yeah, so here we have a directive. It is called .if. Name title is done by I and F. It has a special type. It begins a folding block, something that can be expanded or collapsed. And the proposal is actually that you put in an if. The underscore represents the cursor position after the insert. Then you have a new line and the end if. So what else do we have? We have binary includes. Those are a special directive. Then we have source includes, which are a special type of directive. We have macro definitions and so on. So I don't want to go into that much of this detail. Everything that is possible is in the example, and typically most of the compilers are very, very similar. Maybe it's without a dot or with a colon or spelled differently. It shouldn't be a problem to just read this and go through the example. Yeah. Besides directives, there is a second set of possible extensions to the instruction set. There are pseudo opcodes. Pseudo opcodes behave like they were opcodes, so they are translated one-to-one, and they are just alternative names for real opcodes. That's why they are pseudo opcodes. And last but not least, there are illegal opcodes. They are normally only allowed if the CPU mode is the MOS 6502 illegal CPU that's active. And what they have in addition is that they can specify flags and addressing that is then also displayed in the instruction help. Yeah. And basically, that's it. If you are with this, you could achieve, I would say, 90%. And sooner or later, you might end up in something that's so specific for your compiler that you cannot model it with the existing metadata. And if that's the case, feel free to contact me and we will try to include it in the standard. Well, thanks for that. So I hope with this, soon we will have Merlin not only as a running example, but as something that works productively. See you in the next tutorial. Bye.